Antifouling paint is a specialized coating used on the hull of boats. It allows boaters to repel the growth of organisms who have attached themselves to the ship. This potentially affects the speed of the ship, the ability to sail upwind, the durability of the boat, as well as can transfer organisms to other areas. Antifouling paint acts as a protective barrier against corrosion in metal ships and can also improve the flow of water when driving a racing vessel. Antifouling paint was first introduced by Captain Ferdinand Grevert, a German sailor, in 1913 in Chile. Since 1960, the formulation of antifouling paint has been changed thousands of times due to toxic ingredients. Today, antifouling paints are formulated with toxic copper, organic compounds, and other biocides that slow the growth of barnacles and algae. Copper's oxide keeps marine flora and fauna from growing on the bottom of a boat. Toxins such as copper are the key to the effectiveness of these types of antifouling paints. However, not all antifouling paints are the same. They contain different amounts of copper, have different ways of releasing the copper, and have different binders, the material that keeps the copper in suspension. This paint is a type of resin that generally consists of 4 basic ingredients. Resin, which acts as a polymer and holds the paint together while controlling the release of biocides. Pigment. Solvent, which is used to vary the flow and drying speed. And lastly, biocides, which are the active compound, usually copper's oxide or trilophyll, which repels the fouling. The polymer in antifouling paint is the resin component. This type of resin found in antifouling paint is called an epoxy resin. It is a polyether resin that contains more than one epoxy group. A pre-polymer of liquid epoxy resin can be created through incremental addition polymerization, using bisphenol A and epichlorohydrine. Once you have a pre-polymer, called a diepoxy, you must mix it with its counterpart, a diamine. The resulting form of resin is created through cross-linking bonds, which is a covalent bond. A crosslink is essentially a bridge formed between the two substances. It occurs because bonds are broken by a catalyst, which releases electrons who move along to the next molecule, breaking its bonds as the cycle continues. The linkage of long lines of polymers makes the molecule less flexible and have a higher melting point, meaning it has stronger bonds after cross-linking. The formation of cross-linking bonds has the ability to turn the polymer from a liquid to a soft solid. Resin also occurs naturally in some plant life and increases when the plant feels it is under stress. Natural resin acid is a collection of carboxylic acid, mainly an abiotic type acid. Although resin, the binder of most paints, is a tough surface, it is not permanent. Epoxy resin is made up of polyether, which is built up from monomers, which have a 3-membered cyclic structure known as an epoxide ring. The carbon atoms in ethylene oxide are trigonally sp2 hybridized. This means one orbital from each carbon atom overlaps with the atomic orbitals of the oxygen atom. The side-to-side overlap between the carbon and oxygen atoms form a pi bond. This explains the ability of the epoxide ring and results in an angular bond structure. The epoxy resin varies in physical and chemical properties depending on the type of solution it is in. Generally, epoxy resins are non-crystalline structures and are good insulators. Epoxy is a thermoset polymer, a polymer that, when cured, becomes tough, stable, and resistant to most chemicals. Since epoxy is a thermoset polymer, it has a high melting and boiling point. Epoxies are insoluble in water and most solutions, except rubbing alcohol and acetic acid. This is why antifouling paint is useful for the bottom of hulls, because the epoxy resin doesn't allow the paint to dissolve in water. As you may have guessed, there are plenty of ecologic and social issues with antifouling paints. Firstly, before alternatives were developed, a chemical called tributyltin caused many marine populations to collapse and has also been known to increase the growth of fat cells in humans. However, since innovative formulas have been created, the main pollutants are now copper compounds. When copper is released into a marine environment, it creates a dead zone, otherwise known as a hypoxic area. Hypoxia is a serious problem our world faces with the increasing amounts of pollution that we create. When an area becomes hypoxic, it no longer contains a livable oxygen level for its inhabitants. Copper will also have a larger impact on the marine area depending on the pH balance of the water. The use of paint has become a social issue. Safe alternatives to antifouling paints such as Econa, which uses non-metal compounds like trilophyll, are now available. This is giving the polluting vessels an easy out, however many do not wish to spend the extra money to take care of their environment. Luckily, in 2008 the use of antifouling paints with TBT was banned, as well as Washington State's recent law over banning copper anti-fouling paints by January 2018 on all recreational vessels. Steps like these are going to be the ones that help preserve our environment for the future.